So we're in the note packet on the E3. A couple of things going on today. So one, we're going to do the E3 notes, and then I'll give you the E3 homework after we get done with the notes. And then at the end of class today, you're going to get a take-home formative. That's going to be your independent learning assignment for tomorrow, is the take-home formative. No, because you're not going to get it until the end of class today, so that you don't do it in class today. Yeah. So, what? Because I have to give you something to do tomorrow. Yeah, I do actually.
Not to give us.
Yeah. So that's what's going to happen. So if you could do the 3 warm-up problems. There's only 3.
Why is it independent work day?
So you might have noticed, you might not have noticed that on the E homework, so far we've had E1 and E2, at the end of the last few problems, we've been kind of thinking back to Unit A, Unit B, Unit C, and Unit D, okay? And we're doing that intentionally because when we come back from winter break in January, it's going to be like 2 days and then it's finals. Because it's like we get 1 week of class, and in that, so we get like 2 days of notes, and then we got to start studying for our finals. Because we have finals the next week, the second week that we come back. Yeah, I know. Crazy. It's in like 5 weeks is your semester final. So we've been going through, and we will start doing more like, just so that we keep remembering what we're doing and all that fun stuff. Okay? So, order of operations on the first 2. Please excuse my dear Aunt Sally. So PEMDAS is what we got to remember. Please excuse my dear Aunt Sally. Those 2 get done at the same time. Okay? So the first thing that I would do here is I would do this 2 times 3. We have 1 minus 6 plus 4. 1 minus 6 is negative 5 plus 4 gives me negative 1. Thumbs up, got it? Didn't get it. Thumbs up, got it? Thumbs to the side, oops. Thumbs down, had no clue. That's too good. Right? It's too good. Too good. Yeah. Exponent first, so I'm going to do that part first. 2 cubed. What does 2 cubed really mean? 2 times 2 times 2, right? 3 times, right? Okay. So 2 times 2 is? 4 times 2 more is? 8. So this is 8 here. Lots of people are going to put 6 there, but that's 8 because it's 2 times 2 times 2, not 2 times 3. Okay. Then 4 times 2 is 8. So we get 8 minus 8. And what is 8 minus 8? 0. 0. Fractions. Oh man, loves the fractions. So you first got to figure out if we're adding, subtracting, multiplying, or dividing. Because adding and subtracting, we do the same thing. So if we're adding or subtracting, that's one way to do fractions. Another way is multiplying. Another way is dividing. Which one are we doing here?
Subtracting.
We're subtracting. So if we are adding or subtracting fractions, what do we need to have? We got to have a common denominator. So if I'm looking at 8 and 2, what is my common denominator? 8 is. Okay? So then I got to adjust my fractions. Okay? Do I need to adjust the first one at all? No, because it's already in a denominator of 8, so that one's going to stay 5. what do I multiply 2 by to get 8? Multiply by 4, which means I gotta multiply the top by 4. 1 times 4 is 4. Then what do I do? So subtract the tops, or add the tops, add or subtract the tops. What about the bottom? Keep it the same, okay? So then this would become 5 minus 4 is 1 over 8. And then at the very end, what do I have to do? Nope. Now in this one, nothing, but what do I look for? If I can do what? Simplify or reduce it, okay? All right, yep, so we're all about simplifying and reducing at the very end so that our final answer is in reduced. Okay? All right, love it. Steps. Now I know we've written these steps down so many times. They should be second nature to you. We should be able to go right around the room. We're going to start with Alex. What's step number 1? Alex. How do we get rid of the parentheses? We distribute. Yes, we do. We distribute. So many. There we go. We distribute to get rid of the parentheses. Step number 2, Nora. No. We clear our fractions if we have. We still haven't had any ones where we've got multiple fractions to clear, right? We'll get to it. We'll get to it.
No.
Alright? Okay? Lisa, step 3. Combine like terms. Do you remember, Lisa, what makes a term like? They gotta have the same variable, and they gotta have the same exponent on those variables. Yeah. Oh, my Lanta, all of them erased on that one. Oh, Jazz, I don't even get to ask you what step number 4 was. It's right there already. Oh.
How many questions are on the phone?
I don't know, I haven't made it yet.
Oh, no. Did you make it?
What?
You make it?
Yeah.
Oh, I didn't know that. I think you just got it.
No.
It's crazy.
And step number 5 is multiply and divide. Okay? Okay. And then what do we do at the end when we don't have answers at the bottom of our page?
You gotta check your work.
We gotta check our word. Because that makes us be happy. Alright? Well, would you like being right? Because I don't like being wrong. Alright, let's do this. Oh, look at these complicated things. Okay, so first let's do,
Take number 2 out of there.
just gone?
No, you got keep it up.
Just boom? You want me to do number 2 and you guys do number 1? Like that way?
Yeah.
We can do that way.
Yeah.
Well, we can do number 2 first.
I'll do
All right.
2.
So, we're going to do number 2. First one was parentheses. Do we have any parentheses to get rid of?
No.
No, done. Step number 2 was fractions. Do we have any fractions that we need to clear up? No, done, gone. Okay, step number 3, combine like terms. On the left side, so now I'm just looking over here on the left side. Do I have any like terms that I need to combine?
Oh, we got a couple.
What do we got?
-5, -2.
-5 and -2 combine to be what? Yep, they do. Okay. Right side, do we have any like terms to combine? 2K and K? What do those combine to be? 1K. Yep. And now that we've combined like terms, now this looks like a problem that we've been doing all week, right? Okay. So which way do we want variables to go? Jess, since you didn't get a question to answer, which way do you want the variables to go? You want variables to the left? You want variables to go right? You want variables to the left? That is a great choice. So we're going to subtract K from both sides. Because then that makes this K go away. That gives me then 2K minus 7 equals 8. Now, since Jazz chose variables to the left, That means numbers have to go which way? Go to the right. So what step would we take to get the numbers all on the right side? Add 7 to both sides? Yes, ma'am. That's what exactly we would do. So we would add 7 to both sides. Right? So then these go away, right? Oh, those go away. That's what you want, right? Right? So then we got 2k equals 15. Okay? Is that what you had, Austin? To that point? Then how did you finish it off? By both sides by 2? Love it. Does that make that go away? Make that go away? And then that gives us, you didn't have me yesterday, you had Mrs. Silva. I'm sure she said the same thing. The reason I like showing all my work like this is because right there I can say, ooh, is that a fraction that can be reduced? And is that a fraction that can be reduced? No. So I'm going to leave it as is. K here equals 15 x. All good? Love it. Pick one more. 1, 3, or 4. 3? Why? Because it looks so complicated?
No, it's easy.
It's easy if you do what? Well, not yet. You can't combine like terms yet. We got to distribute first, right? What makes the distributive part easy? No, not the parentheses. Mr. H and I have been harping on this all week long. What should we do right before we even start doing the problem? Draw in our arrows. Yep, draw in your arrows. Okay? So this one especially, because this -2 has to be distributed in to both of those. Not just one, gotta go into both. Now let's pick your head up. And then on this side, 2 has to go in to both. Okay? Alright? So, Braxton, on the left side, you get the blue one. The 3 is 3, right? That's just going to be our normal 3 there. What is -2 times 6x? -12x. What is -2 times -5? +10. Good job. Okay. Lily, you get the red ones. 2 times x. 2x. 2 times -4. -8. And then that's -7x there too. Okay. So we got to do a little distributive first. Draw on those arrows makes us remember that it's got to go into all of those terms. Okay. All right. Now we got to do some combining of our like terms. So if I am here, I would say we could combine those 2 on that side, and that means that makes our left side be -12x plus 13. Would you agree with me on that? Yeah? Okay. And then I think we can combine these 2 over here, and that would be -5x minus 8. Would you agree with me on that one? Yeah? Okay. All right. Now you think you can solve it from there? Go for it. You haven't done so already. Dylan, which way do you want variables to go? Left, variables to left. Okay? Alright, so if I'm going to go variables to the left, then I'm going to go plus 5x, right? Because that's opposite of that, which means it's going to be plus 5x there. So then that goes away, and then this gives me -7x plus 13 equals -8. Okay. Column of variables went left, which way do the numbers go? You go to the right, so how are we gonna make the numbers go right? Subtract 13. Exactly. Negative 8 minus 13. Oh, what do we got? What kind of 12? Negative 21. Yep. Will, how would you finish off this problem? By what? By negative 7. Yeah, that negative sign is going to come along with it. We're going to divide by negative 7. Divide by negative 7. And then that's going to give us x equals positive 3. And since we haven't done it yet, let's just do a quick check on this one. So if I plug positive 3 into my problem, then that's going to be 3 minus 2 times 3 times 6, right here, 3 times 6 is 18 minus 5. Well, then 18 minus 5, that's going to be 13. 2 times 13 is going to be 26. So I get negative 23 for the left side. On the other side, I've got 2 times 3 minus 4 minus 7 times 3. 3 minus 4 is negative 1. 2 times negative 1 is negative 2. 7 times 3 is 21. Negative 2 minus 21 is negative 23. And because those two are equal, we can brag. We did that. We weren't scared, right, Jake? Nah, not scared at all. Alright. Give you 10 minutes. Actually, probably when it is. Most of you, I think, are already done. Do numbers 2 and 4, if you haven't done so already. 2 and 4. So, and number 4. We'll do number 4 only because I'm on that page right away. Okay? So then this becomes negative 9p plus 5 equals 5p plus 5. Okay? Then, if we want to subtract 5p, then that's going to be negative 14p plus 5 equals 5. Then subtract 5. That's going to be negative 14p equals 0. Then divide by negative 14. And 0 divided by anything is 0. 0 there. If I plug in 0 back into my original problem, negative 9 times 0 is 0. So that one goes away, leaves me just with 5. 0 plus 1 is 1, times 5 is 5, and 5 equals 5. Okay. Checks out. Works out. Love it. Okay. And then number 1, I'm going to combine 32 and 20, and that's going to combine to be positive 12. Which way you want variables to go?
I know.
Austin, you want to go to the right? Okay, I like it. Because then that means we're going to get positive variables. So that goes away. That leaves me with 12 equals 7x plus 14. If the numbers went to the right, that means that, the variables went to the right, that means the numbers have to go to the left. between that. And then divide by 7, right? Okay. Oh yeah. A lot of you had this, which is still the same thing. Okay. Or you could have also had this. All three of those are acceptable answers. Okay? But what I was saying before about making sure that that negative sign is seen, I saw a couple people that had this. Or the negative sign was even closer to the 7.
I did not do that.
Like in there. Like, you know what I mean? And the negative sign was smaller and lighter and all that fun stuff. Make it so that somebody old, like me, okay, can see it.